Hey everybody, we're going to talk about Circumcenter and Incenter today. So earlier in the unit we did a paper that had all of the notes and we talked about Circumcenter. So the Circumcenter is the perpendicular bisector of the sides of the triangle, and they all intersect at that one point. So all of these are perpendicular bisectors. The Circumcenter is always equidistant from the vertices. So in this picture here, you can identify that all of these lines are equal. So we're going to use a diagram to answer the following questions. List the perpendicular bisectors. So the perpendicular bisectors are the points that go from the center and make right angles. So that would be PF, that is PD, and PE. So you have to make sure that you're identifying a segment that goes from the center to a perpendicular bisector. Name the circumcenter. Well, it's P. List all congruent segments. So what I want to do first is I want to list the side segments. So we're told that BE is congruent with EC. We're told that AF is congruent with FC. We're told that AD is congruent with DB. And then remember that the circumcenter is equidistant from the vertices. So that means AP is congruent to CP, which is congruent to BP. All right. Moving down here, Z is the circumcenter, and we need to find each angle measure. So for TU, we know that these two segments have been cut in half. So this would be 19 plus 19, which is equal to 38. VY, this has been cut in half. So 34 divided by 2 is 17. UZ is the same distance from, so it's a circumcenter to a vertice, so it's going to be the same distance as a circumcenter to a vertice, which is the same thing as VZ. So I'm going to write same as VZ, which is 21. We have WV. So WV is going to be a little tricky because we don't know anything that would help us. We do know that these segments are cut in half, but we don't know anything about the whole segment. So we have to look. We remember that from the vertice to a side, it's a perpendicular line. So if we draw this triangle, we have 15 and 21 as the hypotenuse, so we need to find this distance of x. So we do the Pythagorean. That's the whole reason why we did the Pythagorean the other day. So you're going to do 21 squared is equal to 15 squared plus x squared. So you get 14.7 because it comes up to 14.69. And then we need to time TV, so that means we take 14.7 and we multiply it by 2. So we get 29.4. Okay. So it's pretty much just understanding what is equal to what and where you can look for a right triangle. So I'm going to do one more with you on this side. So H is the circumcenter of triangle BCD. We need to find the missing measures. So we need to find GD. Well, that segment was cut in half. So I wrote down the answer. 12 divided by 2, 24 divided by 2, which is the answer is 12. We have BC here. So these two segments have been cut in half. So that means it's 7 times 2, which is 14. We have EH here. EH, we know that it's this segment here. So we need to draw the right triangle. So I'm going to draw it. Here's the right triangle. It's 7. But we don't know any other measure. So what else can we use from the picture to fill in this right triangle? Well, you know from the circumcenter to a vertex, it's the same thing as all circumcenters to vertices. So circumcenter to vertex, this is 13. So we're going to do 13 squared is equal to 7 squared plus x squared. Solve that for x, and you get 10.95, so we'll just round it to 11. Okay. So now we need to move on to FD. So FD is here. We don't know anything about FD or CD, so we can't say, but we have another right triangle here. So I'll draw that right triangle. You have this is 3. This is 13 because HB, HC, and HD are all the same. So this one is 13 squared is equal to 3 squared plus x squared. 13 squared. Solve that for x. You get FD to be 12.6. And then we need to find CD, which is this segment has been cut in half. So this is 12.6 times 2, which is 25.2. Okay. All right. Flip it over. Now we're going to talk about Incenter. If you remember back, Incenter is where all the angle bisectors meet. So the angle bisectors of the angles of a triangle intersect at a point called the incenter. The incenter is always equidistant from the sides. Okay, so if you look at this picture here, all of these are equidistant. Okay, so list the angle bisectors. Remember that is where it goes from the vertex to the incenter. So we have AP, we have BP, and we have CP. What's the incenter? That is P. And we want to name all of the congruent segments. We have BP is congruent to PE, which is congruent to PF. And if we go back to Incenter, these segments here are the same. So FC is congruent with EC. We have DB is congruent with BE. And lastly, we have AD is congruent with AF. All right? So we got to use this information down here. P is the incenter. We need to find each missing measure. So we need to find NP. Well, if you remember, NP is equidistant from the incenter, so all of them are the same. So it's the same as MP, which is 8. NK here is the same thing as OK, which is 17. We need to find PK. We don't know anything about PK because we can't make any inference. So if you draw this right triangle here, this would be the OK, which was 17. PO is the same thing as MP, which is 8. So we need to use the Pythagorean. We're trying to find the hypotenuse, so it's x squared is equal to 8 squared plus 17 squared. We need to solve that for x. So if you go ahead and do that in your calculator, you get 18.8. Then we need to find LO down here. Again, we need to do another right triangle. So we have, looks like that. The hypotenuse is 13. And this is 8. So we have 13 squared is equal to 8 squared plus x squared. Put that in your calculator and solve for x, and we get 10.2. Okay, it's honestly just looking at the picture above and determining what you have and what else you can fill in with the picture. I'm going to skip over number 2 because I want to go down to number 3. It's a little bit different. So we're told S is the incenter. So we know that all of these angles have been cut in half. When we read this, we have to go PRQ. So this whole angle here is 8x minus 10. We have RPQ. This whole angle here is 4x minus 14. And we have PQR, which is 7x minus 5. So this one's not really going to use any of the distances that we used above. It's just going back to the fact that the 3 interior angles of a triangle are equal to what? They're equal to 180. So 4x minus 14 plus 7x minus 5 plus 8x minus 10 is equal to 180. Combine like terms, we get 19x minus 29 is equal to 180. 19x is equal to 209. We get x is equal to 11. So what we need to do here is we need to plug back into each of our equations we have. So we have PRQ, which is right here. So 8 times 11 minus 10 is 78. We have RPQ, so 4 times 11 minus 14 is 30. And PQR is 7 times 11 minus 5, which is 72. So we got the big ones. The other ones are just identifying what the angles are in half. So if we look here, we have RPS, which is half of this angle, which was 78. So half of 78 is 39. We have PQS, which is half of 72. So 72 divided by 2, which is 36. We have PRS, which was half of 30, which is 15. I might have done this backwards. RPQ. Oh, yeah, I labeled these wrong. I'm sorry. So we got to go back and redo these. So we have PRQ, which is 78. We have RPQ, which is 30. And this is 72. So one of them was right. So here is RPS, half of 30 is 15. We have PQS, so half of 72 is 36. We have PRS, which is half of 78 is 39. And then we have PSR. So we need to figure what this angle right here is. So if you know that this is 39 and this is 15, you can do 180 minus 15 minus 39 to get 126. Okay. I hope that helped. Again, just go back to the picture and always identify what you can fill in as similar segments up in this picture. All right. Sounds good. Bye.